Today we're going to look at Chapter 4.9, Oxidation Reduction Reactions. We're going to talk about what these reactions are. We're going to look at how to assign oxidation states, do some examples, and look at characteristics of oxidation reduction reactions. So an oxidation reduction reaction is also called a redox reaction. And so these reactions are reactions in which one or more electrons are transferred. This means that elements change their charge from reactants to products. Most reactants that produce energy are redox reactions. And so some examples of this would include photosynthesis, combustion reactions, both examples of redox reactions. So oxidation states, oxidation numbers, are a way to keep track of electrons in oxidation reduction reactions. They're imaginary charges and covalent bonds. So there's a table in your book. I'm going to kind of rewrite it, but it's table 4.2 on page 149. And so this is going to go through how to assign oxidation states. Some rules you need to know. So if you just have an element, say for example like solid sodium or oxygen gas, the oxidation state is 0. If you have a monatomic ion such as sodium or chlorine, the oxidation state is the charge of the ion. If you have fluorine, it's a -1 in its compound. So if you have hydrofluoric acid or phosphorus trifluoride, the fluorine would be assigned a -1. For the oxidation state of oxygen, it's a -2. So if you had water, you would assign oxygen a -2. If you have carbon dioxide, each oxygen would be a -2. Now there is an exception to this. And that exception is peroxides. So in this case, oxygen is a -1. And then hydrogen, for example, if you have hydrogen in water, or hydrogen in hydrochloric acid, or the hydrogens in ammonia, they would be assigned a +1. So when you assign oxidation states, the sum of the oxidation states in a compound must equal 0. The sum of an oxidation state in a polyatomic ion must equal the charge of the polyatomic ion. Oxidation states can be fractional, and we'll look at an example of that. And then this is kind of just for format. When you write a charge, it's written as the number and then the plus or the minus, and then oxidation states are written as the plus and then the number. So for charges, it would be N plus or N minus, where N is the number, and for oxidation states, it's the charge and then the number. So positive, then N, or negative, then N. So then if we look at transition metals are in groups 3 through 12. They can exhibit multiple oxidation states. They vary by 1. The highest oxidation state is the same as the group number for groups 3 through 7. And groups 8 through 12, those oxidation states decrease because of electron pairing. So let's do some examples of assigning oxidation states. So what is the oxidation state of carbon in carbon dioxide? So if we go back to our rules, the sum of the oxidation states in a compound must equal 0. So this must equal 0 because it's a neutral compound. So we have, we know oxygen from our rules is a -2 for each oxygen. So we have 1 carbon, we don't know the oxidation state of. We have 2 oxygens times the oxidation state of a -2, and that has to equal 0. So the carbon oxidation state plus a -4 equals 0. So carbon would equal a +4. So let's do another example. What is the oxidation state of nitrogen in NO3, in the nitrate anion, polyatomic ion? So we know that this must equal a -1 because it's the charge of the polyatomic ion. So we have 1 nitrogen plus 3 oxygens. Each oxygen we know from our rules has an oxidation state of a -2. That's all equal to a -1 charge. Whoops. And charges, we just went over. And actually, you don't need to write the 1 up here, you can just do a negative. The charge is written as the number and then the charge. So if we look at this, we would have our nitrogen plus a -6, which would equal a -1. And so N would equal a +5. So let's do one with a transition metal. What is the oxidation state of iron? So this is a neutral compound, neutral ionic compound, so it's going to be equal to 0. We have 3 irons plus 4 oxygens. Each oxygen has a -2 oxidation state. So 3 irons plus a -8 equals 0. 3 irons equals a +8. So iron, the oxidation state of iron would be a +8/3. And yes, oxidation states can be fractional. So let's look at characteristics of oxidation reduction reactions. So in this reaction, we have sodium reacting with chlorine to form sodium chloride. So I'm going to assign oxidation states. Sodium is an element, so it has an oxidation state of 0. Chlorine is an element, so it has an oxidation state of 0. In sodium chloride, this would be a -1. This is a +1. And so we want to talk about in terms of what's happening to the sodium, what is oxidized, what is reduced, what's happening to the chlorine. So sodium is oxidized because it has a loss of electrons. You're going from 0 to a +1, so there's a loss of electrons. Chlorine is reduced because you're going from 0 to a -1, so there's a gaining of electrons. And so sodium is oxidized, there's a loss of electrons. It is also the reducing agent. And when I say it's the reducing agent, it's because it's the electron donor. Chlorine is reduced. Sorry, chlorine is the oxidation. We're not doing, chlorine is the oxidizing agent. Because it's the electron acceptor. And so whenever you're given one of these reactions, you're going to assign oxidation states, determine what's being oxidized, what's being reduced, and then what is the reducing agent, what is the oxidizing agent. And I find it helpful to use mnemonic devices for this. And so I have two mnemonic devices. So the first one is oil rig. And so oil rig, oxidation is loss, reduction is gain. So oxidation is the loss of electrons, reduction is the gaining of electrons. The other mnemonic device I have is Leo says Ger. And so loss of electrons is oxidation. Gaining or gain of electrons is a reduction. So I'm going to do one more example of identifying the oxidized and reduced, and then the agents. And so we're going to do the combustion reaction of methane gas plus oxygen gas to form carbon dioxide gas and water vapor. So the first step I'm going to go through is assign oxidation states. So we know hydrogen is a positive 1. There are 4 of them, so that would mean that carbon would be a negative 4. Oxygen, this is an element, is 0. Here, oxygen in the compound is negative 2. There are 2 of them, so negative 2 times 2 is a negative 4, so that means carbon has to be a positive 4. Oxygen's a negative 2, and hydrogen's a positive 1. So what we're looking at is methane and oxygen. And we're going to determine which one is being oxidized and which one is being reduced. So methane, and here's methane. The carbon, and what I'm specifically looking at in methane is the carbon here, and then the carbon over here. And so we have gone from a negative 4 to a positive 4, which means that carbon has lost electrons. So Methane is oxidized. Carbon so it's oxidize. Oxidation is loss. And then we're looking at oxygen here. And you can see the oxygen here is a 0. And you can look at oxygen here. So the oxygen has gained electrons. It's gone from a 0 to -2. So the oxygen is reduced. So then we're going to talk about what's the reducing agent, what's the oxidizing agent. So methane is an electron donor. So it's the reducing agent. Oxygen is an electron acceptor. So it's the oxidizing agent. So there's some practice for you to do on the worksheet with assigning oxidation states and then assigning what is oxidized, what is reduced, what's the reducing agent and oxidizing agent. You won't be able to finish the whole worksheet because the balancing part we will do in class, but you can finish the first part of the worksheet.